Good day. Fluorimetry Module 6. Today we are going to learn about types of fluorescence, factors affecting fluorescence, quenching and its effect. Spectrofluorimetry is a type of electromagnetic spectroscopy that analyzes fluorescence from a sample. This technique uses ultraviolet light that excites the electrons in the molecules of certain compounds. As the excited state is not stable and causes them to emit light and returns to the ground state. This study or measurement of this emitted radiation is called fluorimetry. Let us learn about types of fluorescence. Fluorescence can be classified into following types based upon the wavelength of emitted radiation when compared to absorbed radiation. According to this, it is classified into three types: Stokes fluorescence, anti-Stokes fluorescence, resonance fluorescence. Stokes fluorescence. The wavelength of emitted radiation is longer than the absorbed radiation. Example of this type is fluorimetry. Anti-Stokes fluorescence. The wavelength of emitted radiation is shorter than the absorbed radiation. Example, thermally assisted fluorescence. Resonance fluorescence. When the wavelength of emitted radiation is equal to the absorbed radiation. Example, mercury vapor at 254 nanometers. Based upon the phenomenon, it means based on its occurrence. Classified into four types: sensitized fluorescence, direct line fluorescence, stepwise fluorescence, thermally assisted fluorescence. Sensitized fluorescence. When elements like thallium, zinc, cadmium and an alkali metal are added to mercury vapor, these elements become sensitized and thus emits fluorescence. Direct line fluorescence, where even after the emission of radiation, the molecules remain in metastable state and finally comes to ground state after loss of energy by vibrational transition. Stepwise fluorescence. This is nothing but the conventional type of fluorescence where part of energy is lost by vibrational transition before the emission of fluorescent radiation. Thermally assisted fluorescence. The excitation is partly by electromagnetic radiation and partly by thermal energy. Let us study about the factors influencing fluorescence intensity. Some of the factors which will influence or affect the fluorescence intensity of a compounds we will learn. Conjugation. A molecule must have unsaturation, that is pi electrons, so that UV or visible radiation can be absorbed. When the UV or visible radiation absorbed, then fluorescence occurs. If there is no absorption of radiation, then there will not be fluorescence. So the conjugation increases the fluorescence intensity. Substituent groups. Electron donating groups. These enhance the fluorescence intensity, whereas electron withdrawing groups decreases the fluorescence intensity. And groups like quaternary ammonium compounds will have no effect on fluorescence intensity. Rigid structures. These rigid structures enhances the fluorescence intensity, whereas flexible structures decreases the fluorescence intensity. Temperature. Increase in temperature leads to increase in collision of a molecules. Therefore, deviation occurs, which results in decrease in fluorescence intensity. So, temperature increases, fluorescence intensity decreases. When the temperature decreases, it leads to decrease in collision of a molecule, which results in increase in fluorescence intensity. So, the temperature decreases, fluorescence intensity increases. Viscosity. Increase in viscosity leads to decreased collisions of a molecule, which leads to enhancement of fluorescence intensity. As the viscosity increases, fluorescence intensity increases. Decrease in viscosity causes increased collisions of molecules, which results in fluorescence intensity decreases. Oxygen. Oxygen decreases the fluorescence intensity in two ways. One is oxygen oxidizes the fluorescent substance to a non-fluorescent substance, whereas the oxygen decreases the fluorescence because of its paramagnetic properties. pH. The effect of pH depends on the chemical structure of the molecule. Here example you can see the phenols. Phenols in acidic condition they are undissociated and they do not give any fluorescence. So in acidic condition there will not be any fluorescence. Whereas in alkaline condition the phenols are dissociated and gives a good fluorescence. So in alkaline condition we can observe the fluorescence intensity. Photochemical decomposition. UV or visible absorption sometimes leads to photochemical reaction. In such cases, fluorescence intensity decreases. So to avoid this photochemical decomposition, wavelength which is not strongly absorbed should be chosen. Next, coming to the effect of concentration on fluorescence intensity. Here, the fluorescence intensity is directly proportional to concentration of the substance. So, when we want to draw a standard graph between concentration versus percentage of fluorescence intensity, we will obtain a straight line that is passing through the origin. That is at low concentrations. But in higher concentration, it doesn't happen. So, in at higher concentration, we will see the deviations from linearity. When concentration increases, the fluorescence intensity does not increase proportionality. This phenomenon is called as self-quenching or concentration quenching. What is the reason for the concentration quenching? This concentration quenching occurs at higher concentration. So, emitted radiation before falling on the detector is being absorbed and re-emitted by adjacent molecules, which leads to internal circulation of radiation. Hence, deviations from linearity is observed. This leads to wrong interpretation of the results. So, this is called as self-quenching or concentration quenching. Next, coming to the quenching of fluorescence and its types. Quenching means decrease in fluorescence intensity. Why it happens? Due to specific effects of constituents of solution itself. These effects may be due to various factors you can observe here, like self-quenching, collisional quenching, static quenching, heavy metals, halides and electron withdrawing groups, oxygen, pH. First one, self-quenching or concentration quenching. At low concentrations, when we plot a graph between concentration versus percentage fluorescence intensity, we will observe a graph that is a line passing through the origin. But at higher concentration, as the fluorescence decreases. Why? Because as the concentration increases, the fluorescence decreases. This phenomenon is called as self-quenching or concentration quenching. Next, pH. So, for example, if you take aniline at pH 5 to 13, it will give the blue fluorescence. Whereas pH less than 5, that means here the aniline exists as a cation, and whereas pH more than 13, it exists as anion. Therefore, it doesn't exhibit the fluorescence. So, the pH also plays an important role in decreasing the concentration. Next, oxygen. Presence of oxygen leads to quenching. Why? Because the oxygen converts the fluorescent to non-fluorescent molecule, and also because of its paramagnetic property, it will decrease the fluorescence intensity. Halides and electron withdrawing groups. These also decreases the fluorescence intensity. Heavy metals. Presence of heavy metals also leads to quenching because of collisions and triplet ground state. Next one, static quenching. This occurs because of complex formation. For example, caffeine reduces the fluorescence intensity of riboflavin because when caffeine combined with riboflavin, it forms a complex. The complexation decreases the fluorescence intensity and hence it leads to quenching. Collisional quenching. Collisional quenching occurs due to several factors like halides, heavy metals, increase in temperature and decrease in viscosity, where number of collisions are increased. Therefore, quenching takes place. So, these are the different types of quenching. And if you want to learn about the principle, instrumentation and application, you can go through the link.